Hello, my name is Selena Norteños, and this is Lab 23, Kirchhoff's Laws, and this is experiment number 3, Kirchhoff's Laws, and this is for Physics 2 Laboratory. So a little intro to this lab. In this lab we used 3 experiments that centered on Kirchhoff's laws to study the behavior of electrical circuits. Using a complex circuit, the third experiment confirmed Kirchhoff's laws for voltage and current. The goals were to confirm Kirchhoff's junction in loop laws and to qualitatively and quantitatively assess how various configurations affect circuit resistance, current, and the voltage. So some of the materials used are shown in this picture over here, and this is me with the lab kit and the materials. The materials included a 9V battery, 2 alligator clips, a snap circuits kit, a digital multimeter, a permanent marker, and masking tape. This is now experiment 3, Kirchhoff's laws. And now, as you can see, I have my 9V battery. I have my 2 alligator clips over here. I have my snap circuits kit, my multimeter, and my resistors here. So I have labeled my resistors with my masking tape: resistor 1, resistor 2, and resistor 3. And right now what I'm going to do is I'm going to turn the multimeter on to dial to 2000 in let me see, in this section over here. So let me place this here. So like this. And now I'm going to measure the voltage of each of the individual resistors. I'm going to measure the resistance, I'm going to do the first one here on camera. 100. Let's try the second one. 983. And then the third one. 986, 7. Right now, I have used figure 21 to create a snap circuit using 2 1K resistors, using one 100 resistor, using one snap conductor, using, let me see what else, 5 2 snap conductors, 1 3 snap conductor, 2 alligator clips, which you see here, and then 1 9V battery, which is here. And then these are all labeled here in figure 21, as you can see. So now what I'm going to do is, well, I have already turned the multimeter onto the DCV section at the 20 mark. And right now what I'm going to do is measure the voltage across different parts of this circuit. I'm going to bring that together. First we're going to start with the battery. So the battery, it's like 9.50, 9.51. Now we're gonna measure the voltage across the 2 AA batteries. I don't know if you can see here. To 0.96. Right now I'm gonna measure the voltage for the resistor number 1, which I'll show over here. This resistor number 1. And I don't know if you can see it with all the cables, but it's down here. 1.93, and then for resistor 2, it's negative, so we have to change to be 8.41, and for resistor 3, $1.02. Okay, there we go. Right now, I have used figure 21 to create a right right now I have used figure 20. Right now I have Now I am going to measure the current going through R1 resistor by connecting the multimeter in series. To do this, I have already removed this 2-snap piece that was originally here, and then I'm gonna touch the red probe from the multimeter to the battery side like this. Just want you to see the multimeter here clearly. So touch this here and then touch resistor 1. You can see how it was 1.93. 1.83, yes. Now I am measuring the current going through R2 resistor by connecting the multimeter in series. I have already removed the 2-snap and the 1-snap connectors. And now I'm going to touch the 1-snap connectors. And now I'm going to touch the red probe to my R2 resistor, and then my black probe to my 2-snap connector. It's giving me 8.3. Now finally, I am measuring the current going through the R3 resistor by connecting the multimeter in series. And to do this, I have removed the 2-snap conductor from here. And now I am gonna place my probes from the multimeter. I'm gonna touch the red probe to the 2-snap conductor, and then the black probe to the resistor R3. I'm gonna observe. Looks like it is 10.23. 10.22. So for our results, this is table 2, which shows resistance, voltage, and current data for figure 21 circuit. As you can see here, I showed the videos previously demonstrating how we measured resistance, voltage, and current for all of these circuit pieces in the last videos. So overall, the voltages and currents that were measured and the theoretical values that were determined in the post-lab using Kirchhoff's laws agreed quite well. High experiment accuracy was indicated by the small percentage error between the measured and theoretical values.